Functions. A relation is a set of ordered pairs. In this particular example, we have 3, 2, 4, 1, 5, 3, and 5, 4 as our relation. The domain of a relation is the set of all values of the independent variable. Our independent variable for this relation is x, and its values are 3, 4, and 5. The range of the relation is the set of all values of the dependent variable. The dependent variable for this relation is y, and its values are 2, 1, 3, and 4. Given our previous example, we want to see how the domain and range relate to each other in this particular relation. Our x values are the inputs, or the members of your domain. The y values are your outputs, or the members of your range. What this means is when we input the value of 3, the output is 2. When we input 4, the output is 1. When we input 5, the output is 3 and 4. Functions. A function is a relation in which each input leads to exactly one output. In this example is the relation of function. We have our independent variable x and our dependent variable y. Our ordered pairs are 0, 13, 1, 18, 2, 23, 3, 28, and 4, 33. We want to compare our inputs to our outputs. So if we have an input of 0, we have an output of 13. If we have an input of 1, we have an output of 18. If we have an input of 2, we have an output of 23. If we have an input of 3, we have an output of 28. If we have an input of 4, we have an output of 33. Since each input has only one output, then we can say yes, this relation is a function. In this example is the relation of function. We have our x, the independent variable, and y, the dependent variable. Our ordered pairs are 2, 20, 3, 18, 3, 16, 4, 14, 5, 12. Our input is 2, then the output is 20. If the input is 3, the output is 18. If the input is 3, the output is also 16. If the input is 4, the output is 14. If the input is 5, the output is 12. Because 3 has an output of 18 and 16, our relation is not a function. Vertical line test. A relation is a function if and only if each vertical line intersects the graph of the relation at no more than one point. We call this requirement the vertical line test. In this example, we want to determine whether the graph is a function. So we have a graph of a circle, and we need to use the vertical line test to see if it is a function. Our first step is to draw a straight line through our graph. Once you draw the vertical line, we want to see how many places does it hit your graph. It touches our graph in 2 spots. Because it touches it in 2 spots, we can say that this is not a function. In this example, determine whether the graph is a function. So for this graph, we want to draw our vertical lines through our graph in several places to see if at any point it crosses the vertical line 2 or more times. Using the vertical line test, we can see that each vertical line touches our graph in only one spot. Yes, this graph is a function. A linear function is a relation whose equation can be put into the form y equals mx plus b, where m and b are constants. Linear function summary. 1. The graph of the function is a non-vertical line. 2. The constant m is the slope of the line, a measure of the line's steepness. 3. If m is greater than 0, the graph of the function is an increasing line. 4. If m is less than 0, the graph of the function is a decreasing line. 5. If m equals 0, the graph of the function is a horizontal line. 6. If an input increases by 1, then the corresponding output changes by the slope m. 7. If the run is 1, then the rise is the slope m. 8. The y-intercept of the line is 0, b. Rule of 4 for functions. We can describe some or all of the input-output pairs of a function by means of 1. An equation, 2. A graph, 3. A table, or 4. Words. These 4 ways to describe input-output pairs of a function are known as the rule of 4 for functions. In this example, use the graph of the function to determine the function's domain and range. The domain are the values of x, your independent variable, and the range are your values of y, your dependent variable. Starting with the domain, we want to see how far to the left and how far to the right our graph is. The furthest to the left that our graph is when x is equal to -4. So -4 is the smallest point for our domain. Looking to the right, the furthermost point to the right is when x is 5. So the largest value x can be is 5. And then our values for x can be anywhere between -4 and 5, including 4 and 5. So our domain, -4 less than or equal to x less than or equal to 5. For our range, we want to look up and down. The lowest point on our graph is when y equals -3. Now we want to find the highest point on our graph, and that is when y equals 4. Our range is -3 less than or equal to y less than or equal to 4. In this example, use the graph of the function to determine the function's domain and range. Our graph starts from the left and goes down, and then at the point 1, -3 turns and then goes up. Domain is all real numbers. For the y, it goes down from left to right, stops at 1, -3, then goes up to the right. We have a point 0, -2.5, and 2, -2.5. These are symmetric points. We also have a point at -1.50 and 3.50. These are also symmetric points. -3, 5, and 5, 5. Those are also symmetric points. The only place where we do not have a symmetric point is 1, -3. All of our y values are greater than -3. Our range is y is greater than or equal to -3. If the parabola had been pointing down, the y value of the vertex would have been the highest point on our graph. Functions and relations. Every function is a relation. In order for a relation to be a function, every input has to have exactly one output. The domain are all the possible values for x, your independent variable. The range is all the possible values for y, your dependent variable.